Let's get started. I would like to introduce Kaizen's own regional manager, Jason Schwartz.
Thank you, Sherry, and thank you everyone for taking the time to join me today. If you are here, you've likely already dealt with foam in your parts washer. Foaming isn't new, and unfortunately it isn't going to magically disappear no matter how much we want it to. Why is foam a problem? Well, it creates spills and slip hazards, reduces cleaning efficiency, drives up chemical consumption, and can even cause pump cavitation or failure, which leads to line down scenarios or costly repairs. In order to properly deal with foam, we have to understand what causes it. The two main causes of foam are low surface tension and entrained gas. If you eliminate either one of these two factors, you can either drastically reduce foam or stop it altogether. First, let's take a look at how to reduce gas. Most of the entrained gas in any wash system comes from the aeration inherent in a spray system. Therefore, immersion washing and vacuum degreasing generally don't have any entrained gas in the system. They therefore much less likely to foam. However, because you generally can't change your entire wash process just because you experience some foam, let's talk about how to deal with gas in a spray system. The easiest way to deal with it is to lower your pump speed or your spray pressure, but that's counterproductive because it'll drastically reduce your cleaning efficiency. Therefore, you really have to look at surface tension. Surface tension, not surprisingly, is a function of surfactant concentration. As you increase surfactant concentration, the surface tension drops up until a critical point. This point is called the critical Micelle concentration. And it's interesting because after this, as you can see on the pictures in the right, all of the surfactant has covered that air-water interface. And the extra surfactant goes into building what are super molecules, basically micelles. These micelles are important because they create a reservoir of surfactant. This extra surfactant is available to wet parts and extend bath life. And that's important because just like lowering the surface tension at the air-water interface, surfactant also lowers the surface tension at the part-water interface. That's how surfactants clean. Without them, there's not a whole lot of point in having a detergent. The problem is this extra surfactant reservoir is also available to propagate foaming. So how do you design a cleaning chemistry that cleans but doesn't foam? Well, enter cloud point surfactants. Cloud point surfactants are interesting because as temperature goes up, solubility goes down. They have an inverse relationship with solubility and temperature. This is really important because as you get to these higher temperatures, those micelles that we talked about earlier actually aggregate together and pull out of solution. You can see this happening because they refract light, making the solution appear cloudy, hence the term cloud point. But the most important part is these aggregates, these groups of micelles, because they've been pulled out of solution, are less available to propagate foaming. Therefore, if you operate a wash bath with a cloud point surfactant in it, slightly above that cloud point, you can drastically reduce foaming, yet the surfactant is still in the wash solution and is available to adsorb at the air-water interface. Basically, the surfactant can still clean without propagating foaming. We get the best of both worlds. Now, if it were that easy, why do I still have foam, right? Well, unfortunately, cloud points aren't static, right? They depend on a lot of different things like pH, salinity, concentration of like molecules. In practical terms, that's dependent on the concentration of your cleaning fluid, the hardness of the water, and the soil buildup in the wash solution. All of these things can vary over time. A fresh bath behaves very differently than a seasoned bath. So what causes foaming in your parts washer? Well, the first and biggest reason that we see foam in parts washers are low temperature. And essentially, the wash bath hasn't reached the cloud point. And this often happens either at the morning or the beginning of a shift. When you're heating up your washer, you start to run it before it hits that temperature set point that you want it to. Most of the time we see cloud points at around 130 degrees Fahrenheit, but they can creep up over time. This is why our sweet spot is generally in the 150 range when operating a wash bath. The second thing that's kind of counterintuitive, but true nonetheless, is low concentration. Essentially, you don't have enough surfactant in the solution to create a cloud point. If all that surfactant remains soluble in solution, it's going to be available to propagate foam. You can also have too much soil, right? That soil is eating up some of the surfactant, preventing the cloud point or driving up the cloud point, right? That's maybe why your fresh bath isn't foaming, and then you drive up the cloud point, and all of a sudden a couple weeks later, after you've dumped a bunch of soil in there, it starts to foam. Lastly, additional surfactants. You may be thinking, well, how can I add additional surfactants into my wash bath? Well, the easiest thing is the new generation oils and coolants contain detergents and surfactants to increase their efficiency in the machining process. Oftentimes, you don't account for these surfactants in your wash bath, and that can cause another source of foam. Sometimes you just can't avoid some of those conditions, and you've got to deal with foam right now. What do you do? Well, the easiest thing is to add in a defoamer. Defoamers work because they disperse quickly across the surfactant layer and disrupt these foam bubbles. They're usually oil-based, which helps them disperse quickly across that air-water interface, but also you have to be aware of silicone oils. Silicone oils are great defoamers, but they're bad for a lot of these post-cleaning and painting processes. Defoamers are convenient because you can use them at all temperatures. You can apply them directly into the sump, but you have to be careful because they're used in small doses. Again, they're oils, right? So you want to use maybe a capful, 1 to 4 ounces per 100 gallons. Too often, I see people dumping cups or quarts of defoamer into their wash tank. 1 to 4 ounces per 100 gallons, that's generally only a capful or 2 for your whole wash tank. If you add in too much, because it's an oil, guess what? You're going to get out slimy parts, and nobody wants that. You've essentially traded away foaming, one problem, for an even worse quality issue down the road. Also, defoamers are expensive, right? They're best used as an intermittent or temporary solution. The better way to deal with foam is to prevent it before it starts. In order to do that, work with your chemical supplier. Find the appropriate chemistry equipment combination for your process. The better understanding you have of your process, the better you're going to be able to prevent the foam. That means knowing if you're using a cloud point-based detergent. If you are, make sure you're operating above the cloud point. Don't allow excess soil to build up in the wash solution, and avoid soils with foam-prone ingredients as possible. Prevent cross-contamination between stages. A lot of times, we'll see a rinse tank begin to foam, even though someone hasn't put any soap in it. Well, what's happening is the soap is dragging out from the wash into the rinse, creating a very low level of surfactant concentration and propagating foam. The easiest way to do all of this is just to monitor your process. Like any process, the better you understand the variables that enter into it: time, temperature, concentration, and cleaning chemical choice, the better off you're going to be in understanding the process and preventing foam. Thank you, everyone, for your time. That's all I have. Sherry, if you have any questions, please let me know.
Thanks, Jason. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.